Thank you everyone for making time today, of course in the busy work week. I want to acknowledge Gurabs, great talk before, Nirti, Alan and Ryan, and Laura as well. To start off, a story from a client meeting last week. I was told AI or die. That was in reference to the commercial arms race, which would be a metaphor for businesses that are not yet adopting or haven't got plans to adopt AI or at least address it. This remains important for where myself sits in this talk, as leveraging AI capability starts with people. Technology is developed by people, so that is the foundation and where this talk will be. The talk is on right data teams, building AI cross-functional teams with data scientists and data engineers from the boardroom. After this talk, there are 4 key takeaways I want to have everyone to have. Understanding the organizational structure of data teams, know the difference between a data engineer and a data scientist, comprehend the first steps in building a data team, and know the boardroom questions that should be asked. Now, importantly, and this was covered before, within leveraging data, most important is the source and data quality as well. So for this talk, I am your source. So to introduce myself, I'm a former data analyst, or I like to sometimes say recovering data analyst. I worked at an ASX-listed financial services firm in the data team of about 20. This gave me an exposure to the data engineering team, so how we ingested data, the data analytics and insight team, and the data science team as well. If I'm honest, I sat with them for a few days and went, this is probably above what I want to be doing with myself. But that gave me a really good understanding of how data moves through a business. Prior to that, I did work in recruitment for the large mining industry, and now the founder of DR Analytics. With this comes a role with the Data Engineer Camp, which is a 16-week boot camp targeted at upskilling consumers into data engineering roles, because there's no real university pathway at this stage for the data engineering skill set. Recent guest speaker at the Brisbane Data and AI Bootcamp, which was where Nate approached me to talk about potentially moving this into the ActiumAI LawTech Commercialization Conference, subsequently meeting with David, and here we are today. With data, and the reason we use data is fundamentally humans have a processing capacity issue. What that means would be that we are great at logic and reasoning, but less so with storage. And we've seen this represented in systems. So for example, banking transactions with millions of different transactions per day. We don't process those, we just have a system that does it for us. We would be logic machines in this case. I bring up the start with why, because building AI capability starts with a use case in mind for a real business. What that may look like, and there were some that were referenced before, so the application, the use of AI in loan applications by Nirti, and the use of AI in leave as well, leave approval, and Alan spoke about the use of AI in looking at creative outcomes as well, with Tony Robbins' former wife. So start with why is the most important when it comes to building AI teams, because understanding the use case then develops the team that you will have in the future. Now, building AI capabilities, there's often 3 pathways, and these interlock with each other, and often it's a combination. As you might have guessed, today we're looking at the first one, hire. There's also training, so building the talent in-house by training people, or outsourcing or done for you. This looks like consultancies or product-based. Mostly there'll be a combination of outsourced and hiring, as you outsource and look to use maybe an AI product, and then train business users inside the organization on using that product. In starting to look at which pathway you'll take, it's important to assess business data maturity. Now, this is from a data platform provider called Snowplow, and looks at the different stages that businesses go through as they become in a stage where they can access their data and then build models to provide business insights, and then decisions can be made subsequently. Now, don't let anyone ever tell you you're not data aware. Everyone's been using a form of data warehouses in every single life that they've had. These are some of the common ones. A data warehouse, and Microsoft describes this, is a central repository of integrated data from one or more disparate sources. This is often digitalized, but with Rolodex, for example, that's taking address, name, phone number, availability, so multiple different data sources to build a repository of sorts. As we go through the 5 steps of data maturity, I'll give a little high-level overview. Data Aware is a company that has no data warehouse, so no source where people can access the data. And there may be ad hoc reporting use cases. Someone brings up a report, not really sure where the data's from, and it couldn't be replicated very easily. Data Capable is when we start to have a data warehouse in place, so a digital resource where different business users can access. At this stage, the data may not be trusted, and there may be some use cases of reporting, but there's a lack of trust involved, as I said. Data Adept is when we start looking at bringing in more team members and having a reliable data source with analytics capability and starting to think about ML and AI. Data Informed would be where there are teams involved and distributed amongst different business functions, able to think about and start to look at one-off use cases of ML and AI. And lastly, we have the Data Pioneers, which is where AI and ML is being used in day-to-day operations with widely distributed teams and custom infrastructure at some level. When you do your research, you'll find that there's many different ways that companies decide to structure their data teams. The more traditional would be Away. They have, down the bottom here, analytics, data science, and data engineering as 3 common divisions. When I worked in a bank, that was the similar structure that they had. If we look over to HubSpot, they've got a more distributed approach. So they have data analysts and data professionals in the different operational departments to specialize in, say, finance, HR, or operations as well. So these are 2 models that large organizations have used with a distributed and then a common structure. As I said, widely throughout Australia, this would be a common use case or scenario where data teams would look like, what data teams would look like. The head of data may take requests from different parts of the business and then distribute these to the relevant parts of the team. What your data team looks like is also up to you, and businesses do change this based on the requirements and the business function. Important to deep dive, and I've mentioned data science and data engineering in my title, but really, what is this and where does it sit in the AI landscape? Some people think data science and data engineering are the same. Some people think they're different. More importantly, there is some overlap. Data scientists are concerned mostly with building models to provide business use cases. So building models for business use cases so decisions can be made. You notice statistics, advanced analytics, machine learning, and AI falls under their remit. They serve the business. Data engineers serve the data scientists. Their role is to get the data from various sources and bring it into a form that is usable by data scientists and machine learning engineers. What they have in common is often programming languages, big data and system operations. They most likely use Python and SQL together, and big data just means large data sets that are changing in velocity and size. But that's great. More importantly, machine learning versus AI. You notice they were both coined there, and they're 2 buzzwords that have been used a lot today. But for some more clarification from Microsoft, AI would fall above, and then machine learning being a subset. Different types of machine learning would be natural language processing. You would also look at computer vision, and then lastly, you'd have large language models as well. So computer vision, that might be a company and one of the clients that I've worked with. they work with receipt data. Now we need to hire an ML engineer who is able to help ingest pictures of receipts from consumers and load that into, or make that data accessible in a structured nature, so data scientists could overlay models as well on top of that. It's great for me to tell you about data engineers and data scientists, but let's hear from some industry members.
Hey John, so what is the role of a data engineer and how do they help data scientists?
Yeah, so let's just start with the data scientists. So data scientists are responsible for helping businesses and stakeholders make decisions from data. The role that a data engineer provides is to prepare the data so that a data scientist can consume it and use it. This may sound simple, however data can come from a number of sources like databases, files, and APIs. And so the data engineer's role is to extract the data, clean it, perform analytics on that data, so that that data scientist can now consume that data set.
Great, thanks.
So Jonathan is a data engineer, Jonathan is a data engineer at Canva. He works with data on a day-to-day from the many different consumers there are. I want to highlight that what Ryan mentioned in mergers and acquisitions was the combination of data sets from different companies. This is where data engineers would become important, as it's being able to transform and create and merge these different data sets into usable data as well. Excuse me, I just flicked the Wi-Fi on. Next, we're going to hear from JK. JK is actually speaking tomorrow, so you'll have the chance to hear from him in person. But I'd like to give you a little bit of a teaser into what he'll be talking about and a bit of his background. This might not be accessible because of the Wi-Fi right now. We'll give it another moment and then try again shortly. Is it going to let me in? Not at this stage, and that's okay. I'll move on. JK answers the same question as Jonathan, highlighting that data scientists are often used to get insights out of the data that's used by businesses, and data engineers are involved with the ingestion and transformation. He also highlights, and this is key on the outsourcing piece, that often at SSW, his consultancy that he works at, they look at product solutions first, so out of the box, before bringing on the people. So that's another consideration. Now we're going to go into the factors in building the right data team that I think are important and from what I've experienced with different companies. One is start with why. So why are you looking to hire this person? What is the use case? And that directs the hiring decision. Next is assessing your data maturity. Now, I wouldn't count myself an expert in this realm by any matter. Again, as I said, recovering data analyst. So I would look at going to domain experts to assess where you're at. That brings to the third point, would be consulting domain experts to help you understand where you're at and where you want to go. Next is more the recruitment piece, and that's around crafting the job brief. In my role, every different data role is different and they're built for the different use case. This gets finer and finer as you go to higher levels. So we're looking at specific types of data, which may be time series. We're looking at specific libraries. So for Python, there's over 129,000 libraries, which adds to the complexity of the situation. We're then also looking at interview processes as well. Now, interview processes is an interesting one for hiring people. Typically, you go in a room, you might talk for a little bit, and then maybe a bit of a use case or a study interview, and then the hire is made. With data, and we'll look at Microsoft for this, they do things a little bit differently. They've got a almost 8-step interview process, starting with the resume, phone screens, and then moving into on-site interviews and a hiring committee. What's different about this specifically is we start moving into technical interviews that are looking at, can you code for this specific business problem? Can you visualize this data? How would you approach this problem that we're facing? So this is the technical interview aspect, and it's not really possible unless there's a use case to start with. In finding the right person in the data and analytics community, some different ways that companies and myself as a recruitment agency have looked at are coding contests. So instead of going and posting a Seek ad to the Brisbane local area, we can look at globally who can solve this problem in the best way, therefore attracting talent from anywhere across the world and the best talent at that. Second, which is not new to the recruitment world and finding talent, would be headhunting. So that's using LinkedIn to find the right people from different businesses. A lot of this comes down to understanding which businesses are using the technology that you need as well. Lastly, GitHub. If anyone's heard of GitHub before, that's essentially the Facebook of the data community. Some people might not like me for saying it like that, but it's a repository for code sources and a collaboration space. And it can be where you find projects for particular staff members that you may want to extend an offer to. Also important in the AI arms race is looking at what other companies are doing as well. This is around the competitive advantage. Now, I thought I'd be clever and try to build an algorithm and a program to scrape information from Seek and then show what was going on in the hiring space. Instead, Luke's done that for me. So he built a script and has published this, open source, which scrapes data from Seek and LinkedIn and Indeed, so job posting sites, and then aggregates that, puts it through an NLP pipeline, and is visualized for our consumption. Now you notice the two skills I said before were SQL and Python. Those are the top two here as most important for skills in the data and analytics space. Both data engineers and both data scientists use those skills. Below that you can see AWS and Azure, their cloud environments, so then looking at digital, and Spark as well, which is an ingestion language. If we go narrow down on Seek advertisements and look at the Australian context, this is with parentheses search, so only job titles with data engineer or data scientist in the actual title. And you'll notice these numbers aren't overwhelming. 235 across Australia is not a lot of data engineers, and noticeably less data scientists as well. This is something I'm bringing up as a number to keep an eye on as it will look to raise in the future, but also to highlight that there is and has been a connotation around the sexy data science. And we saw this in Western Australia, and I've heard this from colleagues there, that in about 5 years ago in the 2018, the large mining giants, Rio and BHP, threw money at data scientists to hire them because they wanted data science models like everyone else. They wanted to be building at the forefront. That was great, but what they didn't have was the clean quality data to build the models upon. That's where the data engineers come in. So data engineering has been becoming more popular in the last few years, and we can see that being a rise because all the talk about building AI capability starts with having accessible, clean data to build a model upon. To tie in cross-functional teams, Deloitte says we need 3 things: collaboration, vision, and technology. Collaboration, that can be seen as the intersect in that Venn diagram that I showed before. So the data scientist and the data engineer. And you've got the business asking the data scientists about the use cases that they can use models for. We have the vision, so we want a team that's working towards the same goal and is aware of what the business is trying to do. Lastly, we have technology, so the importance of using tools that allow for collaboration and visibility across different areas of the business. Boardroom questions for consideration. This is more of a high-level overview of what I've gone through, but important questions for the board to ask. What's the use case that we have in mind for AI? It's not enough to say we need it. There needs to be a case for why we need it. Do we hire, train, or outsource? Or a combination of them? Another decision to be made. We have to look at data maturity as well, and that's important in taking stock and investigating where you currently are and where you need to be. Lastly, really the question is, do we need AI? And with the competitive landscape, that will most likely be yes. If so, what's going to be the cost to implement it? What do tools cost? What do people cost? If I'm to give you a ballpark figure on data engineers in the Australian climate, be looking at juniors around the 120,000 mark, with seniors on 200,000 plus. Data scientists, similar, maybe a little bit below, but as the specialists become more specialised, then they attract higher figures as well. Netflix notably released an AI-related role with a base salary of 300,000 and a top end of 900,000 USD. So that's what we're looking at in the US, which is leading this market. I just wanted to reference the Actium AI pyramid. Nate and David have spoken about this to me, and this ties into the risks associated and decisions that need to be made around building AI capability. Now this slide is blank, and that's for a reason, because the future of data teams is unknown at this stage. It could be a data engineer and a data scientist together. We could have what HubSpot has, which is a large team with data engineering, analytics, and data science. Or you could have an AI specialist that only uses specific products and is able to create business value that way. We're not sure exactly. Businesses will drive that decision. That's everything from me. Thank you very much for listening, and any questions, I welcome them.
Doug, how would you go about employing a big team? Say someone came in and said, I need 30 engineers and 30 scientists, 60 teams.
Yeah. What is that? Immigration. Yeah. Outsourcing to different countries. Building a big team, I'd say there's a consideration when it comes to building a big team. There's risks associated in not having the right processes in place. So there's a commonly used word called technical debt that gets thrown around. Basically that happens when businesses move faster than their processes, and therefore when they look to expand further, say you want to go to now 100 people, they can't do that because they have to address the underlying issue of documentation and best practices. So I guess there is I think that's more so the risk. How would you go about doing that? Start with the documentation and processes, and then put the people in to fulfill.
Do you know of any universities in Australia who has a course degree in data engineering?
There's two that I've seen. I think Monash had one, and I think RMIT. But the thing with data engineering is the tools that are being used in the modern landscape are being updated probably every year or so. So can universities keep up with that? Not really sure. Mage, for example, is a new ETL tool which is going to take over Airflow, which was the previous one that was used. That's a recent use case in the last 6 months.
I've got a question for you to ask Dr. David. If there's 2 universities in Australia who are teaching data engineering, ask David, how many universities are teaching law? 54. Interesting, isn't it? A LawTech conference, and the lawyers are going to need the engineers. We have a huge problem on our way. We all have this glowy goal in front of us. How are we going to do it? So this is one of the reasons I asked Doug to come along. He's our portal to get this happening.
The portal. Thanks, Nate. Did you have a question, sorry?
I did. Mine's really simple and educating me. So you had up on the thing a system, someone architect, a solutions architect. So where do they fit in the picture? You've got engineers, scientists, is it them by a different name or is it something different? Hang on, let me find that. I wrote it down.
That was JK.
JK, yep, he's one of those. What's one of those?
I'd love to play the video. Solution architects more so fit in with describing the problem at hand and the resources needed. David and Heidi can probably describe this really well. A solutions architect might map what's needed, and JK explains this as well. If a client engages him, first looks at the landscape and what's needed. Is it a product that's needed? Is it a data scientist that's needed? Is there a data engineer that's needed to solve the use case?
So that probably answers my second question, is that you were then saying in your what to do next, define the use case, hire and train, data maturity, and then cost of putting someone in. Most of the people I talk to, their problem is they can't define the use case because they don't know what the art of the possible is.
Mm-hmm.
Is it that engineer that will help? Is that the system architect that helps them decide what they need to do? Because what they're doing is stumbling at I know I need to do something, but I don't know what to do.
Yeah, no, it's a really good question. I think the solution architect comes into it, and that's what consultancies would call that position. So the position to analyze what solutions needed for your problem. I think there's a range of different companies that offer that service at a consulting level. The consultant would be called a solution architect or a consultant as well. When it comes to semantics for data engineering and data analytics roles, there are a few gaps in what each position means, and there's no dictionary as much. So a data analyst could do something that's a lot more like data engineering.
You mentioned you're tracking kind of the positions around the data engineer and the data scientist. What sort of trend have you seen within Australia across those aggregator kind of job platform sites? Do you see that trend ticking up? Do you see, or?
In regards to, it's more so people that I see in the industry as real trends from speaking to clients. I haven't mapped the, say, Google Word or the ads increase. Personally, I would say there's a lot of people graduating from data science and not a lot of jobs to support that. Whereas data engineering is becoming more prominent as businesses have the data, but it's not accessible and cannot be visualized as simple as visualized, or build models upon it as well.
So Nate alluded to this before, but one of the challenges is communicating to firms and industry more broadly the need for data engineers and the need for data scientists, which doesn't translate to interesting jobs. How would you go about communicating to these firms what their need is? Is that purely the role of a solutions architect or a business analyst, or is there greater or broader advocacy needed to help communicate the future needs in order to translate the desire for new technologies into a practical solution?
That's a really good question. And mostly around the education piece for building data and analytics, for building AI capability. What does that look like? I don't think it looks like we need AI. It looks like we need, say, data engineers to start with to create resources that are accessible and clean in quality so we can build great models. In answer to your question, where does the education piece come from? I think that's really difficult because often it's hard to tell someone you think they have a problem if they can't come to the realization themselves as well. And from a business perspective, from myself personally, if I'm a recruitment agent saying you need a data engineer, it's up to the business what needs to be made. So that business needs to be made organically as well from, say, the CEO level, I think, and that comes to education piece at the higher ends of business. If that answers your question. Thank you.